This is the video lecture for the risk register portion of ME 415 and Engineering 466. In the area of risk management, the benefit of doing a risk register is that it allows us to identify the elements in the project plan that could be at risk, also allows the team to identify those problems and take a proactive stance as to mitigating the risk of those problems coming to bear. Also allows the team to prioritize their actions to reduce or eliminate any risk from impacting the project and its timely completion. And lastly, it responds to issues in improving the action plan by getting items in place that the team can act upon in order to mitigate risk in making the project late or not being able to be delivered at all. Some food for thought here. Mario Andretti, famous IndyCar driver, is quoted as saying, "Circumstances may cause interruptions and delays, but never lose sight of your goal." And that is very true in project management. We have to keep in mind what our goal is when we set out with a project and make sure that all effort that we have is focused toward achieving that goal. And one of the big things that can happen that can disrupt you from hitting your goal is risk. So that's why we spend time talking about this. So where does risk from the project come from? This slide looks very similar to what we saw with the design failure mode effects analysis lecture. That's because risk is very much the same for a project as it is for a product or a process, because project management is a process. So a lot of things we had said before can come into play, but you'll see there's slight changes here. For instance, again, we see poor control plans and standard operating procedures. But now things that come into play that can disrupt the project would be things like logistics issues and late shipment back orders. Could be poorly developed specifications again, creating the engineering team to have to do more work than necessary in order to certify a project. Sometimes when you're running verification testing, things don't go as planned, you run into issues. If you're not planning for those ahead of time, they can cause delay on the project. Also, machine availability. If you've got some piece of machinery that everybody else is using, in the case of our projects here in mechanical engineering at Iowa State, a very classic case of a bottleneck for a project would be the rapid prototype machinery, because we get late in the semester and a lot of other teams want to do rapid prototypes. The next thing you know, the machine's not available because it's tied up. There'd be also staffing disruptions, but in the case of project teams, that's usually going to amount to student illness or being away for job interviews or sports travel, any number of things like that. And then lastly, unclear customer expectations. Oftentimes we'll run into that too with a project where the sponsor has an idea of what they want to do on the project at the beginning of the semester, but by midterm or 2/3 of the way into the semester they change their mind. And this is critical to the success of the project, being able to manage what we call scope creep. And I'd like to say it's not a common occurrence, but it occurs far more frequently than we'd like. So teams understanding that and managing that, and you manage that through good communications with your sponsor and making sure they understand that you have to have a very clear set of goals to work against, and that if it shifts, that will cause delays in the project. So, how do you go about mitigating risk? Well, again, you got to ask yourself the same questions that we did when we were talking about the design FEMA, and the same reality still holds true. What can go wrong? How likely is it to happen? What are the consequences when it does happen? And again, just like with the design and managing the project, the risk of uncertainty falls on you, the project manager in this case, and the engineers often serve as project managers, so that's why we're spending time talking about this subject. So, from the standpoint of risk mitigation on managing a project, who's responsible? Well, that's a good question. I found this great chart from Northrop Grumman out of their risk management plan, which we have a copy of that for you to download and read through, and it's well worth reading. It's a very good program that Northrop Grumman put together for the state of Montana for a program they called Inoperability Montana, and we're using risk register format very similar to what's used in this risk plan that Northrop Grumman put together. But anyway, risk activities, you see here on the left column we have things like risk identification, risk registry, risk assessment, and so on, and who's responsible for it. You'll notice that where it says project manager or other specific individuals, or maybe anybody who's a stakeholder in the team. At any rate, these point out who, in a general sense, has to take care of which items are involved with risk. I would highly encourage you at this time to either pause the lecture and read through all of those items, or get a hold of the PDF copy of this lecture and print that slide off and have that for reference. But at any rate, we'll move on to the next slide. How good is your project plan? That's a very good question to ask. Key things that you want to be looking for in a project plan is, are there any resources that may have limited availability? If that is the case, if yes is the answer, could they create bottlenecks in getting your project done? What sort of delay? What sort of risks do they have against your project being done on time? Also, as you look at the elements of your plan, which of those elements in there have the greatest risk of delaying your project? Whether it be, for instance, team members that have to be gone for extended periods for training, or maybe there's, in the case of our college teams, student athletes who have to go off to conference championships, and that can all have an impact on getting a project done. Machines not being available in the shop, material being back ordered. These are all things that have to be looked at. You also want to ask yourself, does your team have sufficient time and the tools to accomplish the tasks at hand? If the answer is no, then you have to give very serious consideration to that task that's being planned. Is it still something that's critical to the success of the project, that it has to be done that way? Or can you alter the deliverable of that task or the fashion in which you do that task in order to reduce the time or the resources required to complete it sufficiently for the project to move forward? Also, what elements of your design have the greatest probability of failure that could delay the project completion? Here again, not doing due diligence in the analysis of your design and having design areas that do not have enough of a design factor planned into the product could be at risk of breaking or failing or not passing some sort of performance criteria that you have. This is why engineering analysis is so important in making sure that your product is going to perform as needed. And having clear customer expectations spelled out and good engineering specifications go a long ways toward making sure that this last element is not a problem for you in your project. So keep in mind that to manage risk, good resource planning is a must. So you got to take a look at your project plan. Look at the critical path. Did you do a critical path analysis on your project? If not, better get one done. But when you do have one, take a look at it. Where is a critical path? Which items that lie along that path have any risk elements along to them that could delay the project? Because if it's on the critical path, you don't get it done on time, you're already late with your project. Also, take a look at your resource plan. Are there any items that are at risk of not being available when you need them, either through back order or overbooked, or not being available to you at the time when you need it? All these things have to be accounted for if you're going to make sure that your project is done on time. Also, take a look at your team. Is anyone going to be unavailable at a critical point during the project? Can you backfill their absence? If not, can you reassign some of the tasks to alleviate the impact of that individual being gone out of your team? Also then, take a look at your design FEMA. Look at the design of your product. Is there any features that you see in there that are high-risk items? Can they be redesigned or eliminated so that you have a better chance of your product being successful when it comes time to certify it or verify it? Also, if analysis or validation testing is required, are there tests where the results are at risk, or that it is uncertain that they will meet your pass-fail criteria? If that is the case, then you want to make sure to get those items tested or validated as early as possible in the plan, so that if the answer comes back unfavorable to the project, you have sufficient time to deal with that item. So, risk management. Well, how do you put a plan together? Well, as mentioned earlier, we've got a great example of a nice risk management plan that Northrop Grumman put together. However, I'll note, for the assignment in 415 and 466, you don't have to write a full report like that. Instead, we want you to do the risk register, look specifically at that item, and get that filled out for your project. And then you're going to write a memo where you're going to outline what you see as your perceived risks in your project, as related to your risk management plan, or your risk register I should say, or as related to your design FEMA, those items in your design FEMA that look to be significantly at risk. See the assignment for more information as to what that memo should entail. So some strategies to apply. Try to know in advance any team members that are going to be absent. Also know too what that team member what skills they have, what are they typically responsible for in your project, and do you have others in the project who can fill the gap. Also understand in advance of any resources, whether it be machine or material or even your staff, that could be of limited supply. And even a person can be of limited supply if something of higher priority requires their time and they don't have time to put in to what you need done. Also then understand which high priority design features may be at risk of reaching your performance goals as related to your performance metrics that you have for a product. If there's anything that's at risk, then obviously you're going to have to spend a lot more time in the design, analysis, and testing of those features and make sure that they are robust enough to meet the acceptance criteria that allows the product to be approved and go into production, or for the process to be improved and be used in production. So here's an example of a risk register sheet that we have in the DMADVR Toolbox. Key thing what you're going to see here, and compared to the Northrop Grumman, we added an extra column in here, but essentially a priority column to allow you to risk or to assess things as being at A, B, C, or a 1, 2, 3, whatever priority ranking you want to use. But the idea is you're supposed to Pareto rank these, that is, get the most critical ones identified as being most important, and those of lesser importance, then you assign a lower priority. There's a title for each risk item. Think of it like a newspaper headline. What describes that issue as it may be. And then the description column allows you to put in a finer description of what the situation is, so that people can understand, okay, why does this risk exist? Then from there, the next few columns are going to allow you to put down what you think is your probability of impact to the project. Do you think it's low, medium, high? You could use a percentage ranking. It's up to you. Or you think it's 10% risk, 50% risk, or 90% risk, or 100% certainty that it is going to be a problem. And then what you want to indicate here is in relationship to 4 key areas on managing a project, which is schedule, scope, quality, or cost. What level of risk does that particular risk item have to any of those areas? Is it high, is it low, or is it not applicable? But you want to track these down. Then the next and last column here is a column where you can put in your plan mitigation actions you're going to take as a team to make sure that whatever that risk item is, you're addressing it proactively. That is, you're taking care of the problem before it becomes a problem. And then the last column we put in there just for you so that you can keep track of things that you're doing, and if you have more than one person working on it, they can get their last actions put down so you kind of know where you're at on each line item for risk. So it's activity since last report or since last entry on the risk register. If you're starting to wonder, is this a living document or not? Once again, just like just about everything else in the DMADVR toolbox, yes it is. It's a living document. Constantly gets updated as new information becomes available so that you can stay ahead of any issues as they occur in managing your project. 5 key areas in the project where you want to focus on mitigating risk, if you haven't already got that from the risk register: schedule, scope, quality, cost, and resources. These key 5 areas are the areas that many projects get graded upon as to their level of success, and so it's important for you as a project manager to keep those key areas managed successfully. So here we have an example risk register. I'm not going to read through this. I will encourage you to stop the lecture at this point, pause it, read through those, or go to the PDF copy of this PowerPoint file and print this page off, or go to the file, the Northrop Grumman Risk Management Plan version 4 that we have a copy of, and print off that page and read through that. This is a fairly good example of what a risk register would look like. So, in review, risk register is simply a table listing all of the risk elements, probability of occurrence, area of impact, and the action planned by the team to mitigate the risk on the project. Of course, key items that play into filling out a risk register are your project plan and your design FEMA and your project charter. Those 3 documents will give you a wealth of information to help you cover what you should be putting in your risk register. This concludes the video lecture for risk management. If you have any questions, ask your instructor or contact Jim Heisey. Thank you.